Good evening. In last lecture, we discussed standard trigonometric limit. Let us revise that. In fact, these are the answers for homework sums. The first standard limit extends to 0, sin x upon x is 1. Now, what are the conditions, or you may say criteria? Angle is in radian only. If it is in degree, you have to convert it into radian. Then angle tends to 0 and it is fully repeated in the denominator. Now limit extends to 0, tan x upon x is also 1. Let us evaluate this limit. Limit extends to 0, sine square 7x upon 11x. Okay. Now this is nothing but limit extends to 0. What is sine square 7x? Sine 7x into sine 7x, right? So angle must be fully repeated. So I write 7. Let me explain first. Then sine 7x upon 7x. Note that original denominator is just 11x. So to get that back, I must write 49. I must write 49x upon 11. You will notice I have written the same thing and that is required. See, sine square 7x, 49 gets cancelled, 1x gets cancelled, 11x. Now I will not write that step, but this is standard limit, its value is 1. Value of this limit is also 1. Here, to take the limit means to replace every x by its limiting value, which is 0. So 1 into 1 into 0. So what is the answer? It is nothing but 0. Is that clear? Now we'll start our sums from exercise 7.4. First part, limit theta tends to 0, sin m theta upon tan n theta. Standard limits require theta in the denominator. So we divide numerator and denominator by theta to get this. Now what is requirement? Angle must be fully repeated, right? So in this step only, see what I'm doing. I hope you will understand this. Limit theta tends to 0, sin m theta upon m theta. See, I cannot just multiply denominator by m. So I multiply numerator also by m. The only thing is, it being a constant, I can write it outside the limit. What about denominator? Limit theta tends to 0. It is tan n theta. Angle must be fully repeated. So we write n theta. We cannot just multiply denominator by n. So we multiply numerator also by n, right? So next step, this is nothing but m into, now I can say value of this limit is 1 upon n into 1. So final answer is m upon n. Of course, we have to say that as theta tends to 0, m theta and n theta both tend to 0. And limit, which standard limit? Limit y tends to 0, sin y upon y equal to 1. Right. So what is the final answer? M upon n. Second sum, let L be the limit theta tends to 0, 1 minus cos 2 theta upon theta square. Now what is 1 minus cos 2 theta? 2 sine square theta. See, this is required and this is not calculus. This is trigonometry. Now sine square theta upon theta square is square of sine theta by theta. Many students at this stage directly write 1 square. No, that is not correct. You won't get full marks for that. Why? Because standard limit is this. So you have to use the result that limit of square is square of limit. So first write this and then say this is standard trigo limit. Its value is 1. So 2 into 1 square, that is 2, is the final answer. Third one, let L be the limit extends to 0, x tan x upon 1 minus cos x. Actually, standard method is 1 minus cos x is 2 sine square x by 2, right? But many students do not understand that. So we will observe that if we have 1 minus cos, we will multiply numerator and denominator by 1 plus cos. So that denominator becomes 1 minus cos square, that is sine square. At this stage, you may say, sir, tan x is sine by cos, so one sine gets cancelled. That is also correct. But here, I have divided numerator and denominator by x square. In the numerator, x is already there and we get tan x upon x. Yes, that is standard limit. Its value is 1. Sine square x upon x square. That value is also 1. And what about this? Here to take the limit means to replace every x by its limiting value, which is 0. Cos 0 is 1. So 1 plus 1, that is 2. So limit extends to 0, tan x upon x into limit extends to 0, 1 plus cos x upon square of limit extends to 0, sin x upon x. See, we have divided by x square, right? Originally it was x tan x. So 1x gets cancelled and that is why tan x upon x. So 1 into cos 0 is 1, 1 into 2 upon 1 square. So final answer is 2. Fourth one, let L be the limit. Limit extends to 0, sec x minus 1 upon x square. Multiply numerator and denominator by sec x plus 1. So that gives me sec square x minus 1 in the numerator, which is tan square x upon x square into this as it is. Now tan square x upon x square is square of tan x by x. Please don't write 1 square directly. In the next step, you have to say limit of square is square of limit. So this is limit x tends to 0, tan x upon x bracket square into limit x tends to 0, 1 upon sec x plus 1. So this is 1 square. What is sec 0? 1. So final answer is 1 upon 2. Right. Now first part, limit extends to 0, 1 minus cos nx upon 1 minus cos mx. If we have 1 minus cos, we multiply by 1 plus cos. So we multiply numerator and denominator by 1 plus cos nx and then by 1 plus cos mx. 1 minus cos nx into 1 plus cos nx is 1 minus cos square nx. This as it is. In the denominator, 1 minus cos mx into 1 plus cos mx is 1 minus cos square mx. This as it is. Now 1 minus cos square is sine square. This is giving 0 by 0 form. Now divide numerator and denominator by x square. Why? Because it is sine square nx. Now let me explain this step. Please listen to me. You're not supposed to write sine square nx upon n square x square. See what I have done. I have multiplied denominator by n square. Can you see n square in the numerator? Yes. Otherwise, what will happen? Function will change. What about denominator? Sine square mx upon m square x square. Why? Angle is mx, then y square because sine square is there. So mx bracket square, that is m square x square. But m square was not there. So we multiply denominator, rather numerator in the denominator by m square. Now see whether we have written the same thing or not. N square cancel, m square cancel, x square effectively gets cancelled. Yes, we have written the same. Now what is the advantage? Again, do not take limit directly. Limit of square is square of limit, right? Now, here standard trigo limit is to be used. Here also we have to use standard trigo limit. Here we have to replace every x by its limiting value, which is 0. Cos 0 is 1. And therefore, what is the answer? N square upon m square into 1. So this is the final answer. Of course, you have to say as x tends to 0, both mx and nx tend to 0 and limit theta tends to 0, sine theta upon theta equal to 1. Second sum, let L be the limit. Limit extends to pi by 6, 2 minus cosec x upon cot square x minus 3. Now what is cot square? 1 plus cot square is cosec square. So what is cot square? Cosec square minus 1. So effectively denominator is cosec square minus 4. What are the factors? Cosec minus 2, cosec plus 2. Numerator take minus sign common to get cosec minus 2. This is giving 0 by 0 form. See, because sine 30 is what? Half. So what is cosec 30? 2. Yes. Can we cancel this? Yes, we can. Now, once you cancel this factor, please do not take limit directly. Mention remaining factors and then take the limit. Again, before you take the limit, see that denominator is not equal to 0. And here it is non-zero. So limit x tends to pi by 6 minus 1 upon cosec x plus 2. Now take limit. So minus 1 upon 2 plus 2. So what is the final answer? It is minus 1 upon 4. Third sum, let L be the limit x tends to pi by 4 cos x minus sin x upon cos 2x. Can we take limit in the first step? No, 0 by 0 form. Cos pi by 4 is same as sin pi by 4, difference 0. Cos 2 times pi by 4, cos pi by 2 is again 0. So we cannot take the limit. Now, what is cos 2x? Cos square x minus sin square x. What are the factors? Cos minus sin, cos plus sin. Substitute. Can I cancel this? I can, because x only tends to pi by 4. X is not equal to pi by 4. So cos x minus sin x is not equal to 0. So it is limit x tends to pi by 4, 1 upon cos x plus sin x. Take the limit. It is better if you write this step. After this, say 1 upon cos pi by 4. Don't write 1 upon root 2 directly. Sin pi by 4 is again 1 by root 2. So final answer is 1 upon root 2. Third one, first part, limit x tends to 0, cos ax minus cos bx upon cos cx minus 1. Now what is cos a minus cos b? Minus 2 sine of first plus second by 2 into sine of first minus second by 2. Now, what is 1 minus cos theta? 2 sine square theta by 2. See, I repeat, calculus is not difficult. Most of the students find trigonometry difficult. That is why they think that calculus is difficult. What is 1 minus cos theta? It is 2 sine square theta by 2. But it is cos minus 1 and therefore minus 1. Okay, I repeat this. Cos a minus cos b is minus 2 sine of first plus second upon 2 into sine of first angle minus second angle by 2. 1 minus cos theta is 2 sine square theta by 2, angle by 2, but minus is there. Okay, next step is important. Now, you have to divide numerator and denominator by x square. Let me explain first. Sine of a plus b by 2 into x upon x. Now you will ask me why this angle? Same angle. See, if x is taken common, then its multiplier is a plus b upon 2 only, and here a minus b upon 2. Okay, yes, into this upon this. Now, angle must be fully repeated. So though denominator is x, I will write a plus b upon 2 into x, right? And therefore I have to multiply numerator by a plus b by 2. They have written this directly. I'll explain that. So a plus b by 2. What about this? Angle must be fully repeated. So effectively, we have multiplied denominator by what? A plus b by 2 into a minus b by 2. That is a square minus b square by 4. And therefore multiply numerator also by this. So we have written the same. That is important. Now, sine cx by 2. Angle must be repeated. So cx by 2. But square is there. So c square x square by 4. We cannot multiply just denominator by this. And therefore we multiply numerator also by c square by 4. But remember, it is 1 upon c square by 4. And that is why 4 upon c square. Now this is standard limit. Its value is 1 into 1 upon 1 square. So this part is 1. And what about this? 4 gets cancelled. Final answer is a square minus b square upon c square. Of course, you have to write this step, write constant outside the limit. Then in the denominator, limit of square is square of limit, and so on. Now you have to mention this, since x tends to 0, these angles also tend to 0, and this standard limit. So final answer, a square minus b square upon c square. Second sum, L equal to limit x tends to pi root 1 minus cos x minus root 2 upon sine square x. Multiply numerator and denominator by root 1 minus cos x plus root 2. Some students change this sign. That is absurd. First term minus second term. So rationalizing factor is first term plus second term. Now what is sine square? 1 minus cos square. So in the next step, I have actually directly written sine square is 1 minus cos square. What are the factors? 1 minus cos, 1 plus cos. Now meantime in the numerator, a minus b into a plus b, a square minus b square. So 1 minus cos x minus 2. That is minus cos x plus 1. Take minus sign common to get 1 plus cos x. Can I cancel 1 plus cos x? Actually, we are used to cancelling 1 minus cos, but here tending value is pi. Cos pi is minus 1. That is why this is giving 0 by 0 form. Once we cancel this, we are in a position to evaluate the limit. Note that here standard trigonometry is not to be used. Now you will ask me how to know that. See, on simplification, it is clearly seen that this factor is giving absurd result. So we have to cancel it. So can we cancel 1 plus cos? Yes, we can. As I said, x only tends to pi, not equal to pi. So 1 plus cos x not equal to 0. Mention remaining factors. Take the limit because denominator is not 0. Remember, cos pi is minus 1. So it is minus 1 upon 1 plus 1 into root of 1 plus 1 plus again root 2. So 1 upon, rather minus 1 upon 2 into 2 root 2. So minus 1 upon 4 root 2 is the final answer. Third sum, limit x tends to pi by 4 tan square x minus cot square x upon sec x minus cosec x. Now, what is tan square? Sec square minus 1. What is cot square? Cosec square minus 1. Now simplify, rearrange the terms. What are the factors of sec square minus cosec square? Sec minus cosec, sec plus cosec. Denominator sec minus cosec. Can I cancel sec minus cosec? Yes, I can, because this only tends to 0, not equal to 0. Now take the limit, means replace every x by its limiting value, which is pi by 4. Sec pi by 4 is root 2. So is cosec pi by 4. So final answer is 2 root 2. Fourth one, L be the limit x tends to pi by 6, 2 sine square x plus sine x minus 1 upon 2 sine square x minus 3 sine x plus 1. Now you have to find the factors. You may say we will split middle term, no problem. But use common sense. Sine 30 is half. So sine x minus half, or for that matter 2 sine x minus 1 is giving 0 by 0 form. So first factor has to be 2 sine x minus 1. So second must be sine x plus 1 in the numerator and sine x minus 1 in the denominator. Cancel this. Don't take limit directly, mention the remaining factors, and then in the next step, take the limit. So limit x tends to pi by 6, sine x plus 1 upon sine x minus 1. Again, see whether limit can be taken or not. If denominator is 0, limit cannot be taken, but here it is non-zero. So take the limit. Sine pi by 6, half. So 3 by 2 upon minus half. Minus 3 is the final answer. Now this is very important. Substitution method. See, standard trigonometry is to be used, but we know that in that angle should tend to 0. See, in this sum, angle is x, but it is not tending to 0, right? So we have to use substitution so that the angle will tend to 0. See, here you have to use allied angle formulae. You should know what is sine of pi by 2 plus theta, what is cos of pi minus theta, etc. So actually we have already used method of substitution. Do you remember where that standard limit extends to a x raised to n minus a raised to n upon x minus a. We had put x equal to a plus h. We have used substitution method at least in 5 to 6 sums, but in trigonometry we are using that for the first time. Let me explain, then write down. Tending value is pi by 2. So we put x equal to pi by 2 plus h, okay, as x tends to pi by 2. Tell me what will be the tending value of h? 0. Simple. I'll explain. See, x equal to pi by 2 plus h means h equal to what? X minus pi by 2. So as x approaches pi by 2, h will approach pi by 2 minus pi by 2, that is 0. Right? Now, what is cosec x minus 1? It will change to cosec pi by 2 plus h minus 1. Now pi by 2 plus means ratio changes, cosec changes to sec. So sec h. Now tell me SIGN sign, angle pi by 2 plus h lies in which quadrant? Yes, second quadrant. In second quadrant, cosec ratio is positive and therefore it is simply sec h. I hope you understood this. If not, you should revise allied angle formula. Okay, write down this. So L equal to limit x tends to 0, sec h minus 1 upon minus h square. Now in the same step, I have multiplied numerator and denominator by sec h plus 1 upon sec h plus 1 for the sake of getting tan square, because sec minus 1 into sec plus 1, sec square minus 1, which is tan square. Okay, minus h bracket square is h square. Tan square h upon h square is square of this. What is limit of square? Square of limit. This is standard limit. Its value is 1. So 1 square. Here to take limit means to replace h by 0. What is sec 0? 1. So 1 upon 2 is the final answer. Yes. Now second sum, limit x tends to a sin x minus sin a upon fifth root of x minus fifth root of a. Again, what is sin a, sin x minus sin a? 2 cos of factor formula. 2 cos of x plus a by 2 into sin of x minus a by 2. Actually, this term does not require anything in the denominator, because even if you take limit of this, of course, you're not supposed to take in this step. But if you take, then a plus a 2a upon 2, that is a. So you simply get cos a. Okay. But we will not be doing that in this step. Next step, divide numerator and denominator by x minus a, because we need this. Angle must be fully repeated. So x minus a upon 2 and therefore into 1 by 2. What about denominator? Denominator is of which type? X raised to n minus a raised to n. Luckily, we have written x minus a in the denominator, right? And therefore, in the next step, limit of this cos separately, because here limit can be evaluated directly into this upon, this is standard limit. Which standard result? See this one, limit x tends to a, x raised to n minus a raised to n upon x minus a is na raised to n minus 1. So 1 upon 5 a raised to 1 upon 5 minus 1, that is minus 4 by 5. Value of this limit being standard trigo limit, its value is 1. Can I write 1 directly? Yes, I can. See, this is angle. Does angle tend to 0? Yes, it does. Is it fully repeated in the denominator? Yes, it is. Is it in radian? Yes, it is. Of course, you have to mention that in the bracket. So what is the final answer? phi a raised to 4 by 5 cos a.